So in this video we'll be going over infinite series and geometric series, and in my last video we went over the sequence of real numbers, if it converges or diverges. So I highly recommend you to watch that before watching this. So let's jump right into it. So we have a of n, which is a pattern, which is equal to a1 plus a2 plus a3 until we reach a of n, right? And we checked if this converges to a number or diverges to infinity, or let's say negative infinity, or so on. Now in this video we will be finding the sum, or sigma. This symbol is denoted by sigma. N is equal to 1 all the way to infinity of a of n. So what we are trying to do is we are trying to find the sum of a1 plus a2 plus a3 all the way up to, let's say, a of n, where a of n will be a of infinity, right? And we are going to check if this converges or diverges. And this entire sum is denoted by s, which is sum of infinity, and we will check if this converges or diverges. So in my last video we were just checking if a of n converges or diverges. So in this video we'll be adding all the terms here. And geometric series, what you want to look for is when you have the sigma, you are gonna have either r of n like this, and you know that this is the ratio, and ratio basically means a of 2 divided by a of 1, or let's say the third term divided by the second term. And let me just quickly write a simple geometric series over here. So 1 plus half plus 1 over 4 plus 1 over 8 until we go to infinity. And basically what we are doing here is we are multiplying here by a half, and the third term, to get the third term from the second term, we are also multiplying by half. So here we have a fixed ratio, and the ratio is half, right? And that is what the r over here is. And to write this in a sigma format, let's write sigma n is equal to 1 infinity, and you can say that half to the power of n minus 1. So the three formats of ratio are r to the power of n, or r to the power of n minus 1, or r to the power of n plus 1. So these are the three symbols that you are expected to know. And now to find the sum, the formula is as follows. So s of infinity is equal to a1, which is the first term in the sequence, divided by 1 minus r. So here, if you want to find the sum of this answer, or the sequence, or this geometric series, is a1, which is 1, the first term, divided by 1 minus, and we have the ratio as half. So it's any two numbers we are multiplying by half, or we can divide it. So a2 divided by 1, a2 divided by a1, so a2 is half, divided by 1 is going to give you 2, right? Oh, sorry, half. Since half divided by 1 is half. And you can do this for anything. 1 over 4 divided by 1 over 2, you will also get half. So that's there. Now let's use a formula. So minus, we want to do half here, right? Yeah. And this will be equal to 2. So it's 1 divided by half, which is 2. So the entire sum is 2 here. Now another thing that you need to look for is, remember the formula, and the three terms, or the three cases that you can have is the absolute value of r, the ratio, is less than 1. This means that it converges. Now the absolute value of 1, of r, is more than 1. This means it diverges. And the third case is r is equal to 1, and we'll look into that later on, but let's not get too confused or complicated here. So if you think about it, r is less than 1. So you are multiplying a term, let's say the first term is 3, and then you multiply by a number which is smaller than 1. So this means you are trying to make the sequence smaller and smaller, right? So that is why it converges. And let's say you are multiplying it more than 1. This means you're increasing, right? Each term is going to increase, and you're going to infinity, by the way. You're never going to stop. So of course it will diverge to either positive infinity or negative infinity. Let's actually do a quick example for when absolute value of r is equal to 1. It also diverges, and let me show you why. So here we have sigma of n is equal to 1 to infinity. We have 1 to the power of n minus 1. So we have the second term over here, and this is the most famous one, by the way. So let's write the first, let's say, 3 terms. It will be 1 plus 1 plus 1. Since 1 to the power of 0 is going to be 1, 1 to the power of 1 is going to be 1 again, and so on. And this goes to infinity, by the way. Keeps continuing all the way to infinity. So what do you think the sum of adding infinite ones is going to be? It's going to be infinity, right? And that's basically it. So this is a case where we don't look that often, and the two other famous cases are when it's less than 1 or more than 1. And one thing that I forgot to mention is the formula, which is a1 divided by 1 minus r, only applies to when r is less than 1. We cannot apply for this one to find the sum of infinity. So that's one thing to keep in mind. Now let's do an example, another question. This was question 1, now question 2. So question 2, we have the sequence 5 minus 5 over 4 plus 5 over 16 minus 5 over 64. Now what do you think we should do here, the first step? The first step is to find if there is a constant ratio that we are multiplying here. So what we can do here is we can divide the second term divided by the first term. So negative 5 over 4 divided by 5 will be multiplied by 1 over 5, and this is negative 1 over 4, right? So we are multiplying each term by negative 1 over 4, and even here to get 5 over 16 we multiply negative 5 over 4 multiplied by negative 1 over 4. So we have the ratio, the constant ratio, as negative 1 over 4, and we can use a formula here since it is less than 1. Always remember that to find the sum here. So the first term is 5 over 1 minus, let me actually write the formula over here. So a1 over 1 minus r. So the ratio. So there is a minus in the formula, and the ratio is minus 1 over 4. So it will be minus 1 over 4, and these two can be added then, and this will be 5 over 4, which is equal to 4. So the sum here is equal to, as infinity is equal to 4, and it converges. Now let's do another example, and the next one is a bit tricky, so I want your full attention. So question 3 is sigma of n is equal to 1 all the way to infinity, and we have 3 to the power of n minus 1 minus 1 over 6 to the power of n minus 1. Now the first thing that we notice in this question is that we don't have that format of r to the power of n or r to the power of n minus 1, or the third case. So somehow we need to convert this fraction into this format so we can see and use that formula. So what I'm going to do here is I'm going to split this fraction into two parts. So 3n minus 1 divided by 6n minus 1, and 1 minus 1 over 6n minus 1. So like this. So let's do that. So it's going to be equal to sigma of 3n minus 1 over 6n minus 1 minus 1 over 6n minus 1. Actually, let me give it some space here and write here infinity of, yeah, So here we can notice that we can factor in the first fraction n minus 1 outside. So it is going to become 3 over 6 n minus 1, and we can factor 3 over 6 to be half, right? It's the same thing. And over here we can factor again n minus 1, since n1 to the power of anything is equal to 1, right? So we can write a temporarily n minus 1 here, since it's the same thing. 1 actually is equal to 1 to the power of anything, so it does not make a difference. So n minus 1. So here again I'm going to factor n minus 1 outside as the power, so 1 over 6 n minus 1, and we can see that we have a format of the second case, right? And here the ratio is less than 1 for the half, and the ratio again 1 over 6 is less than 1 here. So here r is equal to half, and here r is equal to 1 over 6. So this is less than 1 and this is less than 1, so it diverges, sorry, it converges, and it converges over here. So we know that this question or the series converges. And to find what value or what sum, we can find the sum of each of these individually. So actually this is supposed to be minus sigma of n is equal to 1 all the way to infinity, and the same thing over here, infinity n is equal to 1. Since we just split it to do it separately, we split this fraction and then we split it into two parts, different parts, separate parts. So here let's apply the formula for the first one. It's going to be the first term, which is, if you do 1 over 2 to the power of n minus 1 and we put n as 1, is going to be half to the power of 0, which is 1, right? Since anything to the power of 0 is going to be 1, so the first term here is going to be 1 minus, or sorry, what was the formula? 1 first term over 1 minus r. So 1 over 1 minus r, and r is going to be half here, and this is equal to 2. So the first part is actually equal to 2. Now for the second part, let's do the same. So find the first term of the series is going to be 1 over 6 to the power of 0 is going to be 1, right? So again, a1 over 1 minus 1 over 6, the ratio, and this is going to be, this is 1.2. So this part also converges and it's 1.2. Now we know that we need to minus them. So it's going to be just 2 minus 1.2, which is 0.8. And since both of them converges, that is why we have an answer. If even one of them diverges, then it would be positive or negative infinity. So the final answer here is actually it converges and it is 0.8. So let's do a different type of example where we don't have a ratio. So question 4 is sigma of n is equal to 1 all the way to infinity, and we have 1 over n into n plus 1. So here we notice that we have a partial fraction, right? And we need to somehow divide this into two fractions. So if you haven't checked my partial decomposition video, I suggest that you do. So here we have two roots in the denominator, so we know that we have two unknowns. It's going to be a plus b, and the factors are a over n is 0, which is n, and the other one is going to be n plus 1, which is negative 1. Now we cross multiply and we solve for a and b. So it's going to be 1 is equal to a into n plus 1 plus b into n. We just use the cover up method for this part. So the numerator is equal to a, and cover the denominator of a, which is n, in this part. So you're left with n plus 1. So that's why I wrote n plus 1 over here. And for b, so you cover up the denominator of b in the original fraction, and you're left with n here. So that's why I multiplied by n. And now you can solve for a and b. So when n is equal to 0, then a is equal to 1, and when n is equal to -1, b is equal to -1. So now let's write that here. So this is gonna be sigma of 1 over n, since a was 1, minus b, which is -1 over n plus 1. So here we don't have that ratio format, right? So r to the power of n, or the other cases that we looked at. So here we need to see and visualize. Let's put some numbers or some sequence here. So let's substitute when n is 1. This is going to be 1 minus half the first term, and the second term is going to be, now n is going to be 2, so substitute n as 2, is going to be half minus half, 1 over 3. So it's going to be 2 plus 1, and then continuing on is going to be 1 over 3 minus 1 over 4, and so on, right? So it keeps going until infinity, when n reaches infinity, which is not even a number, so it keeps continuing forever. Minus 1 over 5, and so on. So do you notice something over here if you look at it? So here we have minus half, and we have plus half over here, and we have minus 1 over 3, and we have plus 1 over 3, and this pattern continues until we have 1 over infinity, where this is so close to 0 that we can say that this is 0. So basically we are just cancelling out whatever terms are coming up, and the only one term that we have over here is going to be 1. So this is not cancelled out with anything, right? So the final answer over here is going to be simply 1. And this basically converges to 1. And this type of series is called telescoping series, where you need to write the pattern and you will see that it's cancelling out. So you need to be very careful and attentive what you are doing. Since we did not have r to the power of n or plus 1 minus 1, so I had to write the pattern and look for any a sequence and cancel it out. So now let's look at two more examples, and I won't be solving them. I will leave it to you guys, and you can put the answer in the comment section, and I'll recheck it and let you know. So question 5 is again a similar example to the last example. So you have n is equal to 1 all the way to infinity, and we have a partial fraction over here, so it's going to be 4 over 4 n minus 3 into 4n plus 1, and you need to solve this now using partial fraction first and then seeing the pattern. And for question 6, we have sigma of n is equal to 1 all the way to infinity, and we have n plus 1 over n. And here I'm going to introduce a new test which is called the nth term test, which basically states if you take the limit of n approaching infinity and we take it from a of n, and if it gives you 0 equal to 0, then it is inconclusive. You don't know if it diverges or converges. So if you get 0, then you can't do anything. So this test is useless if it is equal to 0. And if it's not equal to 0, then you can say that it diverges directly. So here, let's use that test here. So this is the important part where it is not equal to 0. So here, if I take the limit of n, which is approaching infinity, and we take n plus 1 over n is equal to 1, since the highest coefficient of n is 1 here and 1, so we divide them and we get 1, which is not equal to 0. So we can say directly that this diverges. So this test really comes in handy for these type of questions. And that's it. Now, as always, I do have a shortcut method for you guys. So if your calculator has the sigma option, what you can do is you can open it and you can choose. Let's say question 4 here. So it is 1 over n. I'm just typing on my calculator. 1 over x minus 1 over x plus 1, right? And let's choose a x is equal to 1 as n is equal to 1, and we are going to infinity. So I'm going to substitute the infinity with a very large number. So let's say 99,000, right? So let's actually do 9,999 first and see what answer it gives us. So this is going to take a while. So here I actually replace infinity with 99 first, and we got 0.99. So now let's increase it by one more 9, so 999 now, and see what answer it gives us. Since the more closer you go to infinity, the more time the calculator is going to take. And so here I got the answer of 0.999. So you can see it's very close to 1, right? And that's what we got over here. So now let's do another example on the calculator with let's say, do we have an infinity example here? Okay, we don't. But yeah, you can see when you have infinity as the answer for each, whenever you increase that infinity here, I mean this value, it will get closer to infinity, or let's say it gets closer to 0 or negative infinity. So that's it for this video. I will be making a short video on how to do it with the calculator, and I'll see you next time then. Thanks for watching.